Recording started.
This is case study number 10, Rainforest Crunch Resolution by Corey Harlow. So the first thing we want to talk about here is what this particular case study is. It's called the Rainforest Crunch, and it's all about urbanization and the negative effects of it, and how deforestation comes about due to this and other global problems. So this particular case study is a bit longer than all the others, so hang with me here. And so first let's define what land use is. Land use is the way a particular piece of land is utilized by humans and other living organisms. And there's 5 main types of land. The first is residential land, and this is where people live. This includes their houses, apartments, or any other area in which they live in. Then there's the commercial land, and this is where the people work. This is their jobs and industries. And then you've got the agriculture land, and this is where people grow crops and raise livestock. This is where the farming comes in. And then you've got the recreation land. This is simply where humans play, where they hike, mountain climb, hunt, that type of thing. And then there's the wilderness land, which is exclusive wildlife habitat where particular animals live. So there's 3 main types of cities, and then we talk about 2 solutions to the urbanization process. And so the first is the concentric city model, and this is when the central business district serves as the middle of the city, and from there it grows outward. And then there's the sector city model, which develops in an outward pie-shaped wedge or strips, and I'll show you a picture of that in a second. And then the multiple nuclei model, and this is when there's multiple central business districts in which the city develops around in multiple places. Now let's talk about the 2 solutions. There's the green belts, which provide habitat such as forest areas for animals and open space for human recreation while blocking the outward growth of cities. So it pretty much restores the habitat and prevents the growth of cities and more deforestation. And then there's cluster development, and this is housing is concentrated in a restricted portion of the tract, leaving the rest open to wildlife. So that means that housing can only go in this part of the city, and the rest is up to habitat. So here's the different models here. You have the concentric, and you can see here's the central business district, and it grows outward. And then you have the Hoyt model, or what do they call it back here? The sector city model. They're the same thing, and it's just, as you can see, when they grow out in these pie shapes here, the city does. And then there's the multiple nuclei model, and you can see here's the central business district, and then here's the outlying business district, and then the heavy manufacturing, and how there's no real center to this particular city. It grows out in many different directions. So some other terms you might want to know is desertification, and this is once arable land becomes too arid for agriculture due to change in climate. Arable simply means that it can be used for agriculture. So desertification is when this land can no longer be used for agriculture. And then there's old growth forests, which these are forests that have been undisturbed for hundreds of years. They've been growing, and nothing's happened. Probably this little clip art tree over here would be an old growth forest. And then there's the second growth forest, and this is when trees have already been cut and replanted in most recent years by new trees. And then there's 2 types of cutting that are real important in this case study that we learned about. And the first is seed tree cutting, and this is when you cut down a whole forest of trees, only leaving the seeds to replenish the supply. And then there's clear cutting, and this is when you completely deforest the area. So the next thing we talk about, the most important thing probably in this unit, is going to be the water cycle. And so what we learned is that the Earth is truly the water planet, as it's covered by 70% water, and that pretty much nothing can live on this Earth without water. We learned that 97% of the water on Earth is salt water, and 3% of the water is fresh water. We also learned that only 0.003 or 3,000ths of this water can be reached, because the rest is in ice caps or buried deep in the Earth, where it's economically unfeasible to extract it. So the first thing we talk about is the water cycle, and how there's 2 ways that the water starts moving up. The first is evaporation, when the sun heats the water and changes the water into a gas form and starts evaporating. The other way which it can happen is transpiration, and this is when the water and the roots of the plant move up the xylem of the plant and eventually is excreted through the stomata. And so once in the air, either through evaporation or transpiration, the clouds begin to form, and water vapor in the atmosphere cools and can transform into tiny droplets of liquid water. And this is called condensation. As you can see, the clouds form here. Then, once the clouds form, when the condensed water droplets grow too large and the air can no longer support them against the pull of gravity, they fall into the earth through precipitation. And precipitation can come in multiple forms, usually water. Once there's two things that can happen. You can either have one, which is surface runoff, where it just runs right back in the ocean and the process begins again, or you can have the process of infiltration when it's subsurface underground and the water keeps going through the rock until it reaches bedrock, and then eventually it'll once again be deposited into a water supply and the whole process starts over again. So the next cycle we learn about is the carbon cycle. And let me get here for a second. The carbon cycle is mainly a building block of all organic materials and therefore most living organisms, and the majority of carbon resides in inorganic minerals and crustal rocks. So what we learn is the main thing that occurs is first dead organisms decay and the waste byproducts and the fossil fuels are extracted. And once there, the dead organisms are going to be taken in by the roots of the plants and used as nutrients because these dead organisms are going to break down. And the tree is then going to respire and release this carbon dioxide because, you know, photosynthesis takes in the carbon dioxide and releases the oxygen. And the plant respiration is going to start the cycle all over again and create photosynthesis. And or the other way you can do it is the dead organism and waste doesn't start it, and the animals respire and release CO2 in the atmosphere, and CO2 is then taken in by the plants, and the process just keeps starting over and over again. The next thing we talk about is the nitrogen cycle, and we talk about how that nitrogen is fixated and in its natural form it cannot be used by multicellular organisms. So what you have is the organic residues and organic matter that have to be transformed into either ammonia or nitrates by cyanobacteria. And once they're done that, they are released, and these nitrates are then consumed by the plants, and the plants are then eaten by these animals. The animals then either die or their waste is decomposed, and the process once again starts all over again. The next cycle which we talk about is the phosphorus cycle, and the phosphorus cycle is really very, very simple. It's probably the easiest one, and phosphorus is very important, however, because it's a major component of ATP, which is the energy source in our lives. And so what we find is most of phosphorus occurs in crustal rocks or deep in the oceans, and when the phosphate-bearing rock is weathered, the phosphate is dissolved and ends up in the rivers, lakes, and soils. Plants then take up this phosphate from the soil, as we can see right here, and the plant is then eaten by other animals, and the animals then take in that particular phosphorus, and then these animals either poop or excrete their waste or die, and the decomposers then take care of this phosphate, and it once again goes in the soil again, and this just keeps going on and on and on. So, what's the environmental issues with this case study? Well, we got major deforestation occurring because of global warming, or deforestation occurring because of urbanization, excuse me. And then we have global warming occurring due to deforestation. We're releasing tons of pollution in the atmosphere, and we're getting rid of our photosynthetic plants, which reproduce oxygen in the atmosphere. We also are facing major erosion due to the amount of runoff occurring, and we're facing desertification or making arable land not arable. And we also have a concept called percolation, and this is when the infiltration goes through and pretty much erodes and weathers the rock and minerals and gets rid of them. And then we also have habitat destruction due to deforestation. So what's some possible solutions? We can do crop rotation to restore the nutrients in the soil. We can have water conservation to make sure we are using all of the 0.03003% of the water which we have. We can do green belts and cluster development, as we already talked about. We can have control agencies, which is a major part of this thing. And we can also just simply try to reduce the amount of air pollution which humans face. I hope you enjoyed.